Right now at 2 a.m. on July 14th, 2026, the National Hurricane Center issued its daily Atlantic tropical weather outlook. It contained 5 words that, in the peak of hurricane season, you almost never see written with this much certainty. Tropical cyclone formation is not expected. Not in the next 48 hours, not in the next 7 days. Nothing. The Atlantic Basin, the stretch of ocean from the African coast to the Gulf of Mexico, the breeding ground for the storms that have shaped American history and Caribbean geography for centuries, is, at this exact moment, essentially dead. And simultaneously, on the other side of the continent, the eastern Pacific is preparing to explode. The National Hurricane Center's Pacific Outlook, issued the same hour, was tracking a tropical wave offshore of southwestern Mexico with an 80% chance of becoming a tropical depression within the next 48 hours and a 90% chance over the next 7 days. 4 named tropical storms have already formed in the eastern Pacific by mid-July, a pace that is running well above historical average for this stage of the season. Typhoon Makala is currently spinning in the western Pacific at 130 miles per hour, one of the strongest typhoons of the year. Tropical storm Higos is following close behind it. The global tropics are not quiet. They are split, dramatically, unusually, almost precisely, between a Pacific that is running hot and an Atlantic that has been locked shut by a force that forecasters have been warning about for months. And the reason both patterns exist simultaneously, and the reason both are expected to change in the weeks ahead, traces back to the same oceanic event building in the equatorial Pacific, the El Niño that is currently tracking toward potentially the strongest on record. Understanding why the tropics look the way they do right now, and what changes in the days and weeks ahead, is understanding how a single anomaly in the temperature of a patch of ocean in the central Pacific can simultaneously supercharge one part of the world's storm system while suppressing another, and why the apparent quiet over the Atlantic right now is not a reason to stop paying attention. Start with the mechanism. The reason the Atlantic is quiet and the Pacific is active is not coincidence or chance atmospheric noise. It is the direct, predictable, historically documented signature of a developing El Niño. El Niño conditions are helping to create an environment conducive to tropical development in the Pacific, increasing the likelihood of back-to-back storm formation through the rest of July. The warmer-than-average sea surface temperatures spreading across the central and eastern Pacific provide more energy for convection, more heat available to fuel rising air, organize thunderstorm clusters, and develop the rotating circulation that becomes a tropical cyclone. At the same time, the El Niño pattern alters upper-level atmospheric winds in a way that specifically favors tropical development in the Pacific. It creates atmospheric lift and reduces the wind shear that would otherwise disrupt developing storms before they can organize. The Atlantic gets the opposite. El Niño can produce higher wind shear and sinking, dry air over the Caribbean Sea and other parts of the Atlantic, which are hostile conditions for hurricanes and tropical storms to develop. Wind shear, the change in wind speed and a developing tropical system. A column of organized thunderstorms requires relatively consistent winds from the surface to the upper atmosphere. When wind shear is strong, those thunderstorms are tilted and torn apart before a circulation can lock in. Right now, over the Atlantic's main development region, the zone from West Africa to the Yucatan Peninsula where the majority of major hurricanes are born, wind. Shear anomalies are running well above average, specifically in the configuration associated with strong El Niño influence. Hostile winds, particularly over the main development region in Caribbean, are expected to limit activity and contribute to below-average rainfall. Add to that the Saharan dust layer, a massive plume of dry, stable, dust-laden air that swept across South Florida on July 8th, creating visible haze and reduced visibility across Miami-Dade County, and which is now spread across the tropical Atlantic and Caribbean. And you have a dual suppression mechanism, wind shear above and a blanket of dry, stabilizing Saharan air below. 2 of the 3 mechanisms most commonly responsible for suppressing Atlantic hurricane activity, both operating simultaneously, both reinforced by the El Niño signal. The result is a season that, on paper, looks nothing like what the past several years have accustomed forecasters and residents of hurricane-prone areas to expect. Colorado State University's Tropical Meteorology Project team is now forecasting only 9 named storms for the 2026 Atlantic hurricane season, 4 of which will become hurricanes, and only 1 of which will reach Category 3 status or stronger. That is 5 fewer storms and 3 fewer hurricanes than an average season. It would be the fewest storms in any Atlantic season since 2014, the fewest hurricanes since 2015, and the fewest Category 3 or stronger hurricanes since 2013 failed to produce a single major hurricane. Colorado State University's Tropical Meteorology team has calculated that net tropical cyclone activity in the Atlantic for 2026 will be approximately 40 to 45% of long-term averages, less than half of a normal season's activity, less than half. And the season isn't giving any signals of rebutting that forecast yet. The Atlantic basin remains quiet, as expected, and there is little indication that pattern will change anytime soon. With El Nino taking hold in the Pacific and the lack of seedlings in favored development areas, it's a challenging environment for systems to organize. Now the Pacific, because that is where the action is happening right now and where it will continue to intensify in the days immediately ahead. The most active tropical basin in the near term is expected to be the Eastern Pacific, where meteorologists are monitoring several areas of disturbed weather that could become named storms. AccuWeather says the Eastern Pacific is poised to ramp up rapidly, with the basin already producing 4 named tropical storms by mid-July. The specific area the National Hurricane Center is watching most closely right now is tropical wave EP96, a disturbance located a couple of 100 miles south of southwestern Mexico's coast. Producing expected to form during the next day or so while the system moves generally west-northwestward, staying offshore of the coasts T of Mexico. Formation chance through 48 hours, 80%. Formation chance through 7 days, 90%, 80% in 48 hours. This is not a marginal probability. It is a high confidence forecast for storm development. The NHC does not issue 80% formation probabilities casually. This system is going to develop, and almost certainly in the next day or two as you watch this video. A second disturbance, designated CP91, is located several hundred miles south of the Hawaiian Islands. The system is producing a small area of gale force winds on its southwest side, but lacks a well-defined surface circulation. If the circulation becomes better defined, a tropical depression or tropical storm could form over the next day or two while the system moves little. The disturbance is expected to move into less favorable environmental conditions later this week, likely ending its chances of development. For Hawaii, the current NHC guidance is clear: no direct threats within the next 10 days. Any system forming near Mexico would track well south of the islands on its westward path. AccuWeather's hurricane expert confirmed that there are no direct threats to Hawaii over the next 10 days, and that any potential threat would not arrive until late in the month at the earliest, due to one of the zones outlooked near Mexico remaining offshore well to the south. In the western Pacific, the picture reinforces just how active the global tropics are at every longitude except the Atlantic. Index 0.1601. Typhoon Mikala is currently categorized as a very strong typhoon with 130 pH winds, while Tropical Storm Higos has 40 pH winds. Both are tracking westward into the western Pacific. Mikala, at 130 miles per hour, is a Category 4 equivalent storm. The same intensity range as the storms that have produced some of the most catastrophic impacts in Philippine, Vietnamese, and Chinese history. Its existence alongside Higos, alongside EP96 developing offshore Mexico, alongside the 4 already named Eastern Pacific storms of 2026. All of it speaks to a global tropical atmosphere that is anything but quiet. The silence in the Atlantic is not a sign of a calm tropics. It is a sign of a very specific, very localized suppression over one basin, while the rest of the world's tropical weather systems do what the warmer than average global ocean is enabling them to do. Now, the days ahead, and the question of when, not whether, the Atlantic eventually wakes up. Forecasters are watching an area near the Gulf Coast for possible development later this week, a combination of dry air, Saharan dust, and strong wind. Much of the Atlantic basin during the past several weeks, but some of those suppressing factors are expected to weaken during the second half of July. AccuWeather hurricane expert Alex De Silva said a weak area of low pressure could attempt to form along the north-central or northeastern Gulf Coast later this week. This is the first signal of the Atlantic pattern beginning to shift, and it deserves careful attention precisely because of the context around it. Despite the expected lull, the northern and eastern Gulf, the Carolina coast, and the western Caribbean remain areas where rapid tropical development can occur. Even in a below-average year for tropical storms and hurricanes, it only takes one storm to cause significant loss of life and catastrophic damage. It only takes one storm. That sentence is not a cliché. It is the foundational truth of hurricane season risk communication, and it takes on specific meaning when the dominant narrative of a season is below average. The danger of a below-average Atlantic season is not that storms don't form. 9 named storms, the CSU forecast, still means 9 separate systems requiring evacuation, decisions, forecast tracks, and public response. The danger is complacency. When forecasters lead the season's messaging with below normal, residents in vulnerable coastal areas can interpret that as safe, when the correct interpretation is less active than usual, but the next storm could still be yours. Tropical storm. Arthur demonstrated this in June. Tropical Storm Arthur wasn't well organized, but its flooding rains smashed Louisiana's all-time 24-hour rainfall record and produced the wettest June day on record in New Orleans. Arthur was barely a tropical storm. It was disorganized, barely maintaining circulation, the kind of system that gets dismissed in seasonal forecasts because it isn't a major hurricane, and it broke an all-time state rainfall record. That is what a tropical storm, not a hurricane, not a major storm, can do when it tracks over the right geography at the right time. The Gulf of Mexico low-pressure area that AccuWeather is flagging for later this week would not, in current forecasts, become Arthur's successor or something more dangerous. The same suppressive factors that have been keeping the Atlantic quiet, Saharan dust, wind shear, are expected to limit any Gulf development this week. But the fact that forecasters are now watching an area near the Gulf Coast and that some of the suppressive factors are expected to weaken during the second half of July means the window of guaranteed Atlantic inactivity is narrowing. The deeper story here, the one that connects the immediate tropical picture to the months ahead and to the climate signals that have defined 2026, is rapid intensification. From 1980 to 2025, 190 Atlantic tropical cyclones rapidly intensified. Nearly one quarter of these storms rapidly intensified at extreme rates, an increase in maximum sustained winds of at least 50 knots, or about 58 miles per hour, in a 24-hour period. Most, 72%, or 48 of the 67 total billion-dollar tropical cyclones impacting the U.S. since 1980, rapidly intensified. Rapid intensification is the variable that makes below-average Atlantic seasons dangerous even in their lulls. A storm does not need weeks to grow from a tropical depression into a Category 4 hurricane. Given the right conditions, warm water, low wind shear, atmospheric moisture, a storm can make that transition in 24 to 48 hours. In 2025, 4 Atlantic hurricanes, Aaron, Gabrielle, Humberto, and Melissa, rapidly intensified. All 4 reached the extreme rapid intensification threshold. All 4. In a single season. Every named hurricane of 2025 that reached hurricane strength did so through rapid intensification at the extreme end of the observed range. The ocean temperatures that fuel rapid intensification are warmer in 2026 than they were in 2025. Climate Central's Climate Shift Index tracking will calculate in real time how much stronger each named storm became due to ocean temperatures made warmer by climate change. The Atlantic's main development region, SSTs, are currently near average, slightly below average in some spots, which is one of the reasons the season is suppressed. But the North Atlantic as a whole is running significantly warmer than historical averages, and as the season progresses into August and September, the main development region's sea surface temperatures historically rise. In an El Niño year, the wind shear suppression may partially weaken in August, particularly over the Gulf and Western Caribbean, as the El Niño's influence on atmospheric circulation evolves. When that happens, whatever disturbance is in the right place at the right time, we'll find an ocean that is capable of fueling rapid intensification at rates that compress the decision-making window for coastal communities to almost nothing. With the early onset of El Niño and the potential for it to become one of the strongest on record, the number of tropical storms in the eastern Pacific is expected to reach well into the double digits in 2026. Both tropical storms and hurricanes are forecast to be well above the historical average in the eastern Pacific. The eastern Pacific telling us it is in a super El Niño year already. Double digits in named storms from a basin that averages 15 named storms, but has significantly exceeded that in strong El Niño years. EP96 forming off Mexico this week. CP91 potentially developing south of Hawaii. Macala at 130 miles per hour in the western Pacific. And in the Atlantic, 9 expected named storms. Fewer than average, but not zero. And with every remaining storm shaped by an ocean that is warmer, a climate that is more energetic, and a rapid intensification mechanism that has become more common and more extreme in every decade of the observational record. Even in an off year, there is still time to wait, watch, and see. That is the meteorological reality of July 14th, 2026. The tropics are split, the Pacific is surging, the Atlantic is artificially suppressed but not permanently sealed. The Gulf Coast and Carolina shore sit in the E1 geographic zone, where rapid development can happen even when everything else is quiet. A weak area of low pressure is being watched for the Gulf later. This week, the second half of July is expected to bring at least some weakening of the Saharan dust and wind shear pattern, and the peak of the Atlantic hurricane season, statistically, historically, climatologically, doesn't arrive for another 2 months. The next name on the Atlantic list is Bertha. Nobody knows when Bertha forms, nobody knows where it tracks, how quickly it intensifies, or what coast it approaches. What forecasters know, what the NHC Tropical Weather Outlook and every seasonal model and every SST anomaly map is currently telling them, is that the conditions necessary to suppress Bertha indefinitely are themselves beginning to weaken. The Atlantic that is dead today will not be dead forever. For Gulf Coast residents, for Caribbean islands, For anyone who has looked at this season's quiet Atlantic and exhaled with relief, the message from every forecaster watching this pattern is consistent and worth repeating one more time. Below average is not the same as zero. One storm is all it takes. And the atmosphere that builds the next Atlantic storm, the warm water, the disappearing dust, the slowly weakening wind shear, is already in motion. Watch the Gulf. Watch the second half of July. Watch the Eastern Pacific EP96 development over the next 48 hours for a preview of what the global tropics can produce when the conditions line up. And keep your hurricane preparedness current through October. Regardless of what the September NHC advisory says about Atlantic activity, the tropics are increasing. The only question is where the next increase shows up. Subscribe, because EP96 is expected to develop in the next 24 to 48 hours, and we'll cover every tropical development across all three basins as the season moves into its most active window.